Hello everyone and welcome to lesson 7 in our series on addition and subtraction. I'm Miss Tutman. Now before we get started today, just pause the video and make sure you've got paper, something to write with and any notes or jottings from yesterday's learning. Okay, are you ready to get started? We're going to start off by having a look at the practice activity Mrs. Shorrock left you with yesterday. So you were looking at balancing equations and making sure that your addends on one side of the equation were equal to your addends on the other side of the equation. And you were doing that by making sure that if you'd increased one addend, you'd decrease the other addend to keep the sum the same. So we're going to look at these 4 sets of equations and see if they are true or false. See if what's on one side of the equal sign is equal to what's on the other side. And we're going to do this by comparing addends. So first of all, we've got 101 add 99 is equal to 100 add 100. So let's see how these have changed. 101 has had 1 subtracted to make 100. So if I've subtracted 1 from one addend, I need to add 1 to the other addend to keep the sum the same. Has that happened? Let's see. 99 has had 1 added to it to make 100. So I've subtracted 1 from one addend, I've added 1 to the other addend, so the sum is the same. So this gets a tick because it's true. Okay, easy peasy, right? Let's have a look at another one. This time we've got 27 and 56 is equal to 28 add 57. Okay, let's see how the addends have changed. 27 has had 1 added to it to make 28. So if I've added 1 to one addend, I should have subtracted 1 from the other addend. So this should go 56 subtract 1 should be 55. Well, that's not 55, that's 57. Well, that can't be equal, can it? We'll have a little look in a bit more detail in a moment about this one, but we know that this one can't be right because we've added 1 to both addends rather than adding 1 and subtracting 1. So this one gets a cross. Ooh, big numbers. This is where this method really is efficient, because you could have checked this by doing a written method, but it would have taken you a lot longer than using the method we're using now. Again, I'm going to see what's happened to my addends on both sides of the equation. I've got 248,000 and I've got 564,000 is equal to 148,000 add 464,000. Okay, same as before, I'm going to see what's happened to my addends. No need to be put off by these big numbers because I can see only 1 digit's changed here. I've gone from 248,000 to 148,000. The only digit that's changed is the 100,000s digit. That's got 1 less. So I've subtracted 100,000. Okay, I've subtracted 100,000 from one addend, so I need to add 100,000 to the other addend. Let's see if that's what's happened. 564,000 is equal to, has changed to 464,000. What did I say? I said I needed to add 100,000. Well, we're looking at the 100,000s digit and I can see that we have subtracted 100,000. So in this case, rather than subtracting 100,000 and adding 100,000, we've subtracted 100,000 twice. So this is not balanced. Again, we'll have a little look at this in a bit more detail in a moment, but for now we know that this one is a cross. It's not correct, it's not equal. Okay, decimals. Like I said before, you could use a written method to check this, but it's not the most efficient. Now, I remember Mrs. Furlong was really helpful last week when she was talking about how we can view decimals. She gave a great representation with deans, and I'm going to use that to help me. So I could call this 0.27, but I'm actually going to call it 27 hundredths. So I've got 27 hundredths and 56 hundredths is equal to 23 hundredths and 60 hundredths. Let's see what's happened to my addends. So 0.27 or 27 hundredths has had 4 hundredths subtracted to make 23 hundredths. So I've subtracted 4 hundredths. If I've subtracted 4 hundredths from one addend, I need to add 4 hundredths to the other addend. Has that happened? So 56 hundredths add 4 hundredths is 60 hundredths. That is what's happened. So I've subtracted 4 hundredths, I've added 4 hundredths, and my sum is the same. So this last one is true. Let's have a closer look at those two incorrect problems. Okay, 27 add 56 is equal to 28 add 57. So I have looked at what's happening on each side. So here I can see my 27 has been increased by 1 to 28. And what should have happened is my 56 should have decreased by 1 to 55. That would have kept my sum the same. That would have kept my balance equal. However, I've increased my 56 by 1 to 57, and you can see from my balance that that means that one side has increased by 2 more than the other side. So it's not a nice level balance, it's an unlevel balance. What I should have done is subtracted 1. Okay, let's have a look at the next example. Okay, so with this example, again, I've just noted down how each addend has been changed. So I've worked from left to right, but there's no reason why you couldn't start on the right and work backwards to the left. As long as you're comparing the addends and seeing if they're equal or not, then that's fine. So, in this case, 248,000 has been decreased by 100,000. It's had 100,000 subtracted from it to give us 148,000. So that means if I have decreased one addend by 100,000, I need to increase the other addend by 100,000. However, I can see that 564,000 has also had 100,000 subtracted from it. So, from my balance scales, I can see that one side has ended up as being 200,000 less than the other side. So again, it's not an equal equation. Okay, let's have a look at the next part of practice activities. Okay, the last practice activity was to explain the information in this diagram and to show it as an equation, perhaps as a bar model. You might have chosen to represent it in a different way, and to use the stem sentence to explain what's happening. So I'm sure you noticed the same thing as I did first of all, which is that this represents a balanced equation. It's shown on the balance scales, so we know that this pair of addends on the left is equal to this pair of addends on the right. They're going to have the same sum. I decided to start with the addends on the right because I could see I had all the information I needed. You might have chosen to start with the addends on the left, and that's fine too. And I decided I would use a bar model to help me first of all. So I put the information I had on the right into a bar model at the top. So you can see there's my 0.75 kilograms, there's my 0.5 kilograms. And then I thought about how they'd changed to get to the addends on the right. So first of all, I was trying to think about how to deal with these decimal numbers, and then I remembered Mrs. Furlong again, and I decided that rather than calling this 0.75 and this 0.725 kilograms, I would think of them in terms of thousandths. So this is 725 thousandths, and this is 750 thousandths. And that helped me to work out really quickly that the change between these two addends is that this one had had 25 thousandths subtracted, or 0.025. And I've shown that change here on my bar model. 0.75 subtract 0.025 is 0.725. And then I knew that because I had subtracted 0.025 from one addend, I would need to add it to the other addend. So here I have 0.5, and it's shown here in my bar model, and I knew I needed to add 0.025, which I just drew on the side there, and that gave me 0.525, or in terms of thousandths, 525 thousandths. To check that what I'd done worked, I also wrote out an equation. I said that 0.75 add 0.5 was equal to 0.725 add 0.525. And I just showed the change here. I showed adding 0.025 and I showed subtracting 0.025. So let's just double check. I can use the stem sentence to explain that. I have added 0.025 to one addend, so I need to subtract 0.025 from the other addend to keep the sum the same. Your representation might be slightly different to mine, but hopefully you found the same missing number that I did. For the next part of our maths learning, we are going to look at a maths story involving journeys to school. As we go through the story, think about what's different and what stays the same. So, Diego walked for 3 minutes to get to his friend's house. Then he walked for another 6 minutes to get to school. What does this part represent? Yes, that's right. That's the 6 minutes it takes Diego to get to school. And where can you see how long it takes him to get to his friend's house? Yes, that's right. The 3 in the equation and the 3 here in the part-whole model. Altogether, it takes Diego 9 minutes to do his journey. Dana walks for 23 minutes to get to her friend's house, and then another 6 minutes to get to school. What does this represent? That's right, this represents Dana's journey to her friend's house, and this 6 represents her journey to school. What represents Dana's total journey time? That's right, both parts here. Altogether, Dana's journey takes 29 minutes. What's the same and what's different with these calculations? Well, I can see that this addend is 3, this addend is 6, and this sum is 9. This addend is 23, this addend is 6, and this sum is 29. So, what's the same and what's different? Well, the same is that this 6 has stayed the same. What's different is, well, we still have 3 1s in this addend and this addend, but we've added 2 more 10s. Therefore, the sum has 2 more 10s. So our sum has changed. Slightly different from yesterday's learning, today our sum will be changing. Where can you see the extra 10s? You can see it in the sum on the second equation. You can see it in the first addend on the second equation. And you can see it in the part-whole model here. Well done. Okay, Let's have a look at this different calculation from a known fact that I'm sure you all know. 4 add 3 is equal to 7. Pay careful attention and see what changes and what stays the same. Okay, can you tell me what's happened? What's the same and what's different? Yes, that's right. We're still adding 3, so this addend is unchanged, but the first addend has increased by 10. So the sum has also increased by 10. What do you think is going to happen next? Let's have a look. Okay, so now instead of 4 add 3 is equal to 7, we've got 24 add 3 is equal to 27. So what's the same? That's right, we're still adding 3. You can see it here on the number line and here in the addend. What's changed from 4 add 3 is equal to 7? That's right, we've added 2 more 10s. So now we have 24 add 3, and because we've added 2 10s to this addend, we have had to add 2 10s to our sum. So our sum is now 27. What do you think is going to happen next? Do you think you can carry on the sequence and fill in what happens? Can you explain what's happening each time? Pause the video now and have a go. What did you notice happening? We carried on to 94, add 3 is equal to 97. How high did you go? What did you notice happening? What was the same and what was different? Well, each time you should have been adding 3, as you can see on the number line, but you will have noticed that as one addend increases, so from 4 to 14 or 24 or 94 or all the numbers in between that you were looking at, the sum increases by the same amount. So from 4 add 3 is equal to 7, we go to 94 add 3 is equal to 97. We can use this stem sentence to talk about what's happened. So in this example, I've added 10 to one addend and I've kept the other addend the same. So I must add 10 to the sum. Can you pause the video and go back to your previous calculations and practice using the stem sentence to explain what's happened each time? Did you have a good practice? We're now going to use the stem sentence with the calculation below. We're going to do it all together, but before we can do that, you need to just make sure you're sure of how the addends have changed and how they stayed the same. So quickly pause the video, make sure you know how the addends have changed, and then come back. Okay, are you ready? So you can either repeat it after me or you can join in with me. So I can see that this addend has increased by 20 to 24. I can see this addend stayed the same. Let's go. I've added 20 to one addend and I've kept the other addend the same, so I must add 20 to the sum. So 7 add 20 is 27. Well done, everybody. Let's have a look at a different example. 43 add 29 is equal to 72. But what would happen if I increased one addend by 10? What will happen to the sum? Well, let's have a think. I'm adding 10, so my ones digit isn't going to change, but my tens digit is going to change by 110. That's right. So how am I going to change 72? Well, my ones digit isn't going to change, but my tens digit is going to change by 110 to an 8. So my new equation is 43 add 39 is equal to 82. Where can you see the change in the second equation? That's right, you can see that the tens digit has changed by 1 in one addend and in the sum. I've added 10 to one addend and kept the other addend the same, so I must add 10 to the sum. Okay, let's practice with another one. Which addend has changed this time? So I've started with 43 add 12 is equal to 55, and now I've got 53 add 12 is equal to 65. Pause and have a go at using the stem sentence to explain what's changed. What did you think? Well, let's compare our addends. I can see that this addend 43 has changed to 53. The ones digit's still the same. Can you see where there is change though? Yes, that's right. The tens digit has changed. I can see that my 4 tens have increased to 5 tens. So that's an increase of 1 10. My 12 has stayed the same. And my sum, I've still got a ones digit of 5, but my tens digit has changed from 5 to 6. So that's also an increase of 1 10. Okay, repeat the stem sentence after me. I've added 10 to one addend, and I've kept the other addend the same, so I must add 10 to the sum. Well done. We can represent the change using a bar model. So we're looking at the same equation, 43 add 12 is equal to 55, and the increase to 53 add 12 is equal to 65. So my first bar model shows my two addends, 43 and 12, and they show my sum, 55. Where else can you see 55? That's right, both bars combined. If I change 43 to 53, I've added 1 10. So my sum is going to increase from 55 to 65. This addend isn't going to change. Pause and have a go at drawing the bar model yourself, and then come back and see if your new bar model looks like mine. Does yours look like mine? You might have drawn it the other way around, or you might have labelled it slightly differently. Where can you see the change in my new bar model, and where can you see what stayed the same? Yes, that's right. You can see that the 12 has stayed the same. This addend hasn't changed. And you can see that because the bar is the same size and the labelling is the same. And the change you can see in two places. You can see that I've added 10 here, so this bar has got longer because it's now representing 43 add 10, and you can see that the overall bar model has got longer too, to 65. Okay, we're going to say the stem sentence all together, so get ready, go. I've added to one addend and kept the other addend the same, so I must add to the sum. And what do you know about this part of our stem sentence and this part of our stem sentence? Yes, that's right. They're always going to have the same value. So if you've added 9 to one addend and kept the other addend the same, you will add 9 to the sum. If you've added 1,000 to one addend and kept the other addend the same, you will add 1,000 to the sum, and so on. If you want to have a bit more of a practice with the stem sentence, then you can replace these values with values of your own. Okay, time for you guys to have a go now. So for your practice activity today, we're going to start off by using a known fact. So our known fact is 27 add 22 is equal to 49. I'd like you to use this fact to help you solve the below calculations. So think about how the addends have changed and what this means you need to do to the sum. Then we have a bit of a reasoning problem for you. Sam had 43 apples in one basket and 35 oranges in another. Therefore, he had 78 pieces of fruit altogether. So my known fact is that 43 apples add 35 oranges is equal to 78. Sally gave him some more apples, so now he has 63 apples. How many pieces of fruit does he have now? Explain how you arrived at your answer. So have a really good think about how the addends have changed, which addend stayed the same, and what that means for the sum. Make sure you calculate efficiently. And for your final challenge today, I'd like you to see if you can make up your own question, similar to the one on the previous slide about the fruit basket. So you might want to rewind and have a look at that. Okay, remember that one addend will need to stay the same and one addend will change, and that will change the sum. Okay, so come back again tomorrow and we'll go through those practice questions. Well done for all your hard work today. I've really enjoyed learning about addition and subtraction with you, and I'm looking forward to speaking to you again tomorrow. Goodbye for now.